friends. Today we are going to discuss one of the most important topic in calculus, area under the curve. Friends, calculus is broadly divided in two parts, differentiation and integration. Differentiation indicates the rate of change of any particle or anything at any point of time or with respect to any variable. Same way, integration indicates the area under the curve. If we see around us, the things are at the bigger level, but if you keeps on dissecting them, then you can understand that each small thing, if it joins together, forms a bigger thing. Say suppose a building is made up of so many materials like bricks, sands, and if all these are integrated systematically, you will see a structure of building. Same way, you have a glass, you have a buckets, you have a table. If each smaller thing is added together, then it will form a bigger thing. This form the basis of area under the curve concept. And in order to find out the area under the curve in any numerical, we have to assume the fundamental what you say that structure, or you can say the shapes, that is a rectangle. Because why we are taking rectangle? Because the rectangle area is very easy to find out, that is length into width. And further, in any structure, rectangle can fit very perfectly compared to triangle or in circle. So that's why we consider in area under the curve a rectangle a perfect shape. So if you take at the minute level, rectangle will almost fit in any curve. So let us start. As you can see in the above diagram, AB is the curve in which forms for which we have to find out the area. Okay, and we have drawn so many parallel lines, which is almost in the form of rectangle. If you see at the macro level, I will show you how the rectangle will form the basis of area under the curve. You see the diagram carefully. This is the curve. Now we draw the perpendicular to the x-axis, and we have to find the area yeah, that is formed through this vertical lines. Now, in order to find the area, if it is a regular shape, you can easily find out by the formula. But since it is not a regular shape, we have to see how to find it. Now, if we dissect the curve into smaller rectangles, as you can see, like this, then you can easily find out the area. So at the macro level, if you keeps on adding the so many rectangles, then each rectangle will form a basis for the area under curve. If you sum all the rectangles together under this curve, then it will form the total area. So let us see how it will work through the mathematical expression. Now once you again see how it forms, see this, if a small rectangles are added together, then this will form the basis for area under the curve. So let us start the mathematical expression for area under the curve. First we will draw the vertical line. We will assume that the small strips in this curve. Let us see. Let us draw two vertical line, because we have to find out the area. So this, say suppose this is a point, and the another point of the curve is D. Now we have assumed the small strip. We are showing it as a bigger to make you a better understanding. Say suppose this portion is a dx length, and this is the y vertical. Now we have to find out the area. So if you keep adding so many strips like this, vertical strip like this, and like this, then you will be able to find the total area. So area of smaller strips, say suppose dA is the smaller strip area, is equal to, now the smaller strip is just like a rectangle, so it will form that dx is the width and y is the length, so y dx. Now further you simplify, as you have already learned in integration, if you apply the integration, because this smaller piece, integration means nothing but it is the adding. So what we do in the area under the curve, we are adding a smaller strips, that's why we are going to use the integration. So integration of dA is equal to integration of y dx. Now integration of dA is a, and here it is y dx. Now suppose this point is at a x distance from this, better you call it x1, and this point is from another part of the strip, which is this one, like this, it is x2. So this will form the basis of upper limit and lower limit. So here we will put lower limit as a x1, because the smaller part is having a x1 distance, and the bigger part is having a x2 distance. So if we integrate, this will form the basis of area under the curve. Now let us see through some of the example, the area under the curve concept, how we can calculate it. The most simple, let us discuss it, that area of triangle. Now draw a triangle, and they draw a triangle through this. What will the equation of this straight line? Say suppose we take this straight line as a AB, A, B, and take this as a C. Now you are very much familiar with this straight line equation, x plus y is equal to 1, because this is an intercept form, and this will be the 1 and AC will be the 1. So this is the intercept, this is the right angle triangle. If we go through the conventional geometry method, then area of this right angle triangle is nothing but half into base 1 CB into height AC 1. So this is nothing, is equal to just half units. This is quite simple because there is no curve concept. Okay, now we will apply the same curve concept here, and we will find out through the calculus method. Now in order to find out this through the calculus method, we will have to draw a small rectangle strips. Now if you see here, if we keeps on drawing the small rectangle strips, this will form the basis for the whole area, like this, like this, like this, and like this. If you keep adding the smaller rectangle, then and add the area of the entire smaller rectangle, then it will form the triangle whole area. So this is how this basis works. Now you see, a smaller rectangle keeps on adding, further add, if you add, then you will form the basis for the area under the curve. Now suppose we are taking a very small strips, and this strips, so suppose this strip width is dx, because if we If we traverse this strip from any side, if you suppose from C point to B point, then it will form the basis of area under the curve. And say suppose dx is the width and y is the length of the strips. Now let us see through the calculus method. So area of the smaller strip is dA is equal to, it is just like a rectangle, so y dx. Now what this will further implies dA is equal to y, we can put through the equation 1 minus x, as x plus y is equal to 1, so y is equal to 1 minus x dx. Now we apply the integration. Why we apply the integration? Because we have already considered the smaller strips. Now if it keeps on adding the smaller strips, then it will form the bigger area, so that's why we are using the integration. So you apply the integration dA, and here you apply the 1 minus x dx integration. Now solve it further. Again dA is equal to integration x minus x dx. Now you further solve it. dA integration. So before that, let us put the limit. Say suppose integration of dA, you initially the strip area was nil, and after it traversed through the entire triangle, say suppose strip area become A. So say suppose when area is 0, x is 0. Here also x is 0. Sorry, it's not 0. Yeah, it's 0. Okay. Now if the area is A, then how? Now why we are putting x is 0 and x is that we are going to put 1? See, this is the point. Here you can see this point C. From C the strip is traveling, so initially strip is 0 and it keeps on moving from C to B, and then from C to B this point traverses a unit distance, so that's why we are putting the upper limit as 1. So let us move further. So x upper limit 1, here also we will put upper limit 1. So dA integration is A. We can put, we are very much familiar with the integration concept. If you are familiar, then only you can solve the problem under the area of x integration x dx. Here also x dx, x integration, sorry, here if we break it, this is a dx, this is also a dx. We simply solve through this bracket 1 minus x dx, dx minus x dx. So now dx integration x, here we put upper limit 1 0, and x dx integration x square by 2, upper limit 1 to 0. Now if you further solve it, we will see the actual area of this triangle. A minus 0, and we will put upper limit 1, and we will put 0, then 1 minus 0 plus minus the bit, and then we will go for minus 1 square by 2 minus 0 square. Then further we will simplify. A is equal to 1 minus 1 by 2, and this is equal to 1 by half. Area is equal to 1 by half. This is the same answer that we get through the conventional geometry method half unit. See here also you can get through the calculus half unit. Since it is so, it is easy area, but if it is a curve, then you have to apply the same concept, the calculus concept, and it will be easier to understand that. So friends, hope you understood the concept of the area under the curve. If you have anything, you can feel free to ask the same in the comments, and we will resolve your queries. Thank you very much. Till then, it's goodbye and take care of yourself.